A very good morning to everyone. Myself Shivangi Suman, and today I'm your host of today's session. I hope all of you are doing well. So I welcome all of you to this one hour workshop on Next-Gen Fermentation Technology. So if we talk about today's session, So the what we are going to discuss is we are going to discuss all about what are the traditional roots of fermentation. After that, what has shifted into the modern world about fermentation. So what is something that is new about fermentation? After that, how you can enhance the quality of fermentation and all that. After that, we'll be discussing some examples about the technological examples that are new to the world of fermentation, and after that the main focus in the end will be about the future prospects of fermentation technology. Now, before getting into more details about the workshop and starting the actual workshop where you can learn something, we'll quick take a session about the lab that has organized this session for all of you. So let's discuss in 5 minutes about the laboratory. So basically, if we talk about Flavin Labs Private Limited, it is a tech-driven R&D company which is basically committed about lab research. Along with that, we are also helping students in getting training and internships to empower them and having knowledge about different arenas in science, something new that is going on in science. We want students to be aware of that. So that's our motto. Along with research and development, we also want students to keep on learning new things. We are an ISO certified laboratory and we are recipient of BIREC Big 21 grant. Along with this, we have collaborations with CCAMP, and we are accredited with MSME. If we discuss what Flavin Labs actually do as work, so the major work that we do is our major investment is R&D, but along with that, we do some academic work and some industry oriented things. For academic work for students, the main focus, I hope most of the people who are attending today's session are students mainly. So for students, we organize summer and winter training camps, and it's in different modules. So from 15 days to 60 days, or sometimes even for 3 months, you can join modules with us. We provide 1 to 2 days workshop. As you have seen, we have organized a 3-day workshop on mushroom spawn cultivation. We provide 3 to 6 months trainings and projects, thesis and dissertation support we provide to our students. And there is a one very important session that we take of students is biotech finishing school program. It's a 6 month training program in which we help students in getting guaranteed job. So basically we train students in industry specific skills, and then we help them in getting placed. There are certain industry oriented programs, services that we also provide. So we provide food and feed testing, we provide spawn production, and we help you in setting up spawn production plants, and then we sell also spawn. We do mushroom cultivation and sale mushroom farming consultancy. So if you want to set up spawn production plant or mushroom production plant, we provide consultancy for that. And we also provide tissue culture plants, so banana plants, through tissue culture we provide that to the industries and to the farmers. Now we discuss about training modules. We provide training module in all kind of subjects in micro, molecular, biotechnology mixed module, nanotechnology, mushroom cultivation, cordyceps mushroom cultivation. Cordyceps is a medicinal mushroom, and it's very in high demand in India right now. In biochemistry, statistical analysis for life sciences, linkage map and QTL identification, herbal product formulation. So these are the modules, training modules that we provide for the students. And we also help students in doing projects. So you can come up with your project idea, and if that aligns with us, we will help you in guide you with the project also. After that, if we talk about the duration, so we provide that in short term and long term, both from 1 to 2 days to 15 days. And if we talk about long terms, from 1 days to 6 months, we provide 1 month to 6 months, we provide internship training module. You can do training with us both in online mode and in offline mode. So if you want to do in offline mode, you will have to visit our laboratory that is situated in Deen Dayal Upadhyay Nagar, Sultanpur Road, Arjunganj, near Akana Stadium. And if you know about Lulu Mall, then it's 1.2 kilometers from Lulu Mall. And if you want to do workshop, any kind of workshop or training module in online, then you will be provided with experiment videos, PowerPoint presentations, study materials, and then we will be taking your live lectures so that if you have any kind of confusion with your work, we'll deal with that in live lectures. And what you will receive if you do any kind of training or workshop with us, so you will get hard copy and soft copy of the certificate. You will get personalized letter of recommendation. So if you apply for job somewhere, or you're planning to do your master's or PhD from foreign, then sometimes, most of the time, you need letter of recommendation from people from your industry. So students who have done internship or training with us, we provide that to them, and we provide welcome training kit for the offline students. Now, if we talk about today's session, so joining and attending today's session is absolutely free of cost. So you can learn and gain knowledge from today's session, and that's what our motto is. But if you want to enhance your CV, then you can take certificate. So for the price of certification for digital certificate is rupees 299, and for the hard copy of the certificate, if you want to take that, is 699. And constantly there are so many students who ask us that why, if your session is free of cost, and why you take price for certification. So there are certain charges that we have to pay if we take generate certificate, and for that we take this price, because when you are generating any kind of certificate, you have to pay taxations, and there are some additional charge that you have to pay. So for that sake, we take this minimal amount from you, and I hope that most of the students can afford this much of money if they want to, enhance your CV. And if you're not interested in certificate, we absolutely understand that. Please be with us till the end, ask questions, and learn from the session. So our today's guest faculty is Dr. Shubhi Srivastava, and she is going to take your session, today's session. And so thank you so much. This was all about the lab. So now I welcome Dr. Shubhi Srivastava. She is our guest speaker of today's session, and she is currently a guest lecturer at State Institute of Horticulture and Food Technology. She has a strong background in microbiology and food technology, and this blend of microbiome and food tech is going to bring a real practical insight in your today's session. So I hope that you're going to learn a lot. Be with us till the end, and keep posting your questions. We will take your questions at the end. We'll take a question answer session of 20 minutes around. So we'll answer all your questions in those 20 minutes. And so till then, happy learning. I welcome ma'am, please come forward and take today's session. So thank you so much, everyone.
Good morning, everyone. I'm Dr. Shubhi Srivastava. Thank you, Shivangi, for giving me this opportunity for this noble workshop on the topic of next-gen fermentation. Actually, this topic is very important for the microbiology students and as well as for the biotechnology students because this topic also includes both these streams. Because here we are discuss about the technology where microorganisms involved with new technologies, and new technologies also comes from the biotechnology. So our today's topic is next gen fermentation innovations in functional foods, agriculture and nutraceuticals. So, in our workshop, today's workshop, basically we will navigate and landscape of this microbial revolutions, providing a comprehensive exploration of its scientific underpinnings and transformative applications, and as well as future trajectories. Basically, this workshop is structured in four key parts. Okay, so in the first key parts, basically we are discussing about the decoding fermentation. In the second one, we will discuss about the reimagining of our plate on the fermentation technology, and third one we will discuss about the cultivation of a greener world, and in the fourth we will discuss about the road ahead about this technology. So, as we all knows that fermentation is a familiar concept often associated with everyday products like yogurt, beer, breads. These are the daily use product which we are using in our daily lives. While these traditional applications are important, they represent only a fraction of this technology's true potential. बेसिकली फर्मेंटेशन इज एन एंशियंट एंड प्रूवन प्रोसेस. बहुत पुराने टाइम से ये फर्मेंटेशन टेक्नोलॉजी चली आ रही है, और हमारे जो पुराने एंशियंट लाइक पूर्वज थे उन्होंने बहुत पहले एक गन्ने के रस से सिरके का प्रोडक्शन किया था, जिसे हम नॉर्मल अपने डेली डाइट में भी लेते हैं, या घर घर में पिकल का फॉर्मेशन होता है. तो इन सब के पीछे अगर कोई टेक्नोलॉजी इन्वॉल्व है तो वो है फर्मेंटेशन. तो आज की इस वर्कशॉप में हमारा जो मेन मोटो है कि इस फर्मेंटेशन टेक्नोलॉजी को आज के मॉडर्न साइंस के साथ कैसे जोड़ा गया है, और इंडस्ट्री के लेवल पे इस टेक्नोलॉजी को हम किस तरह से यूज कर रहे हैं, इसके ऊपर आज हम डिस्कस करेंगे. तो बेसिकली ये जो आज का वर्कशॉप है ये बहुत इंपॉर्टेंट है, और अगर आप जितने भी लोग अटेंड कर रहे हैं, अगर आप इसमें इंटरेस्टेड हैं और अगर आपको ये इंपॉर्टेंट लग रहा है, तो डेफिनेटली आप इसके सर्टिफिकेशन के लिए अप्लाई करिएगा, क्योंकि फर्दर अगर आप इस स्ट्रीम में आगे जाते हैं इंडस्ट्री लेवल पे, तो डेफिनेटली ये सर्टिफिकेशन आपके लिए हेल्पफुल होगा. तो अब मैं स्टार्ट करती हूँ आज के अपने इस टॉपिक पे बात करना, और आपके जो भी क्वेरीज होंगी, क्वेश्चंस होंगी, उसको हम लास्ट में लेंगे. ओके, so basically fermentation is an ancient and proven process, but one whose full capabilities are only now being unlocked through the powerful lens of modern biotechnology, holding the promise to reshape our world. So, basically, fermentation is a biological process defined by the cultivation of microorganisms such as bacteria, yeast, and fungi to achieve a specific outcome. This can range from the simpler breakdown of a complex molecule like carbohydrate into a simpler ones like organic acids and alcohol. लाइक जैसे अगर हम सिरके का प्रोडक्शन जो होता है वो कैसे होता है, घर में अगर हम बनाते हैं तो वो गन्ने का रस लेते हैं और उसको फर्मेंट होने के लिए छोड़ देते हैं. उसमें कुछ सर्टेन माइक्रो ऑर्गेनिज्म है, वो अपनी मेटाबॉलिज्म के थ्रू उसके अंदर कुछ चेंजेस लाते हैं और वो कन्वर्ट हो जाता है आपका एसिटिक एसिड में या ऑर्गेनिक एसिड में. ठीक है, एंड वो आपका वर्क करता है एज अ बेस्ट डाइजेशन में हेल्प करता है. तो दैट इज ऑल्सो वन एग्जाम्पल ऑफ फर्मेंटेशन. From the millennia, humanity has harnessed these microbial power primarily for the food preservation and creation of culturally significant products like wine, cheese, and temp. However, the contemporary understanding and application of fermentation have expanded far beyond these historical uses. The convergence of fermentation with modern scientific disciplines, particularly genomics and synthetic biology, has transformed it from craft into the predictable and programmable engineering platform, and dramatically broadening its scope and potential impacts. So, this is very important. So basically, this technology includes three main pillars. So firstly, I'm going to discuss with first pillar, that is the traditional fermentation. To understand the current landscape, it is essential to differentiate in these three primary categories of fermentation used in the alternative proteins and food technology sectors. Each pillar utilizes microorganisms with different distinct goals. So in first pillar, like traditional fermentation, this is the most ancient and familiar form. So here I'm going to discuss for the industry, like ancient form. Here I'm going to discuss with our first technology, that is the traditional fermentation. So in this process, basically, the form of where whole microorganism, live microorganism, are used directly and modify and transform a food substrate, often though anaerobic digestion. In the context of modern food innovation, traditional fermentation is being applied to plant based ingredients to significantly improve their sensory and nutritional profiles. By fermentation of the plant proteins, companies can enhance flavors, texture, and improve digestibility. Okay, so the improvement of these technology, basically in this process, microorganism transform the food substrate directly. And if we will talk about the modern applications, so basically this technology applied to plant based ingredients, okay, that enhances the taste, texture, nutritional profiles, improves flavor, digestibility. So माइक्रो ऑर्गेनिजम्स को जब हम एग्रीकल्चर के पॉइंट ऑफ व्यू से अगर देखेंगे, तो आज के मॉडर्न टाइम में इन माइक्रो ऑर्गेनिजम्स का कंजम्पशन so we will improve the texture, flavors, and digestibility. Okay, so the main common example of microtechnology. Okay, in this microtechnology, basically Shytech is the very common example of this modern food fermenting technology. In this technology, basically microtechnology employs Shicotech mycelium to ferment pea and rice protein, a process that mitigates of flavor and enhances the overall appeal of plant-based meat products. Okay, so this is our first pillar, that is traditional fermentation. Now I'm going to discuss about our second pillar, that is biomass. So as you all knows about the single cell protein, that is very common in fermentation technology. So basically biomass fermentation worked on the single cell protein concept. Okay, so in this process, basically the primary goal is not to transform a substrate but to cultivate the microorganisms themselves as a main ingredient. So biomass fermentation leverages the rapid growth rate and high protein content of certain microbes to produce large quantity of protein rich food efficiency. So in this concept, microorganism is a product. So here we are discussing कि microorganism is not converting anything. Microorganism itself is a protein, producing protein and producing a huge concept of biomass production. The most prominent commercial example is the Curon. That is the very common example of this microbiomass concept, which uses filamentous fungus Fusarium venetum to create mycoprotein. And this protein rich base for its entire product line is using the concept and of the biomass production. So this biomass fermentation is our second pillar. So first is traditional and second is the biomass. Now we are going to discuss about our third pillar, that is precision fermentation. So modern biotechnology and microbiology when comes joins together, then they worked on this precision fermentation technology. So, what is precision fermentation technology? This is the most advanced technology of three fermentation pillars, uses microorganism as a programmable cellular factories. Okay, and microorganisms are given genetic instructions to produce specific functional ingredients, and final product is not a microbe or a fermented substrate but a highly purified ingredients that has been separated from the microbial cultures. This allow for creation of specific proteins like whey, casein, enzymes like chymosin, which commonly known as rennet, and flavor molecules like hem, vitamins, pigments, and fats, all without the need of animals. We can produce all these components using this precision fermentation technology. So basically, precision fermentation is not a new invention, but rather a new application of a proven technology. The same fundamental process actually has been used safely and effectively for decades to produce critical compounds for the food and pharmaceutical industries, such as chymosin for cheese making, where and insulin for the diabetes patients. So these are the common examples where we can produce these components using these precision fermentation technology. So these are the three basic pillars. So now I will compare these three pillars. As you know, all the features, if we will discuss about the features, the traditional fermentation has whole microorganism transform a food substrate, and the biomass fermentation has for microbes are grown on their own mass. And in precision fermentation, basically microbes are programmed to produce a specific molecule. And if I'm going to discuss about the examples, so for the traditional fermentation, the main common examples are temps and kimchi. And if we talk about the biomass fermentation, the common examples are the mycoproteins. And if we are discuss about the precision, the common examples are whey, hemp, and some specific important enzymes. Okay, if we will talk about the primary benefits of these three pillars, so in the traditional fermentation, basically we increase the flavor, texture, and improve the digestibility for this, for the help of this traditional fermentation technology. And the if we discuss about the biomass fermentation, the primary benefit is the high volume of protein production. Highly efficient protein we will make from the help of the biomass fermentation. And if we will talk about the precision fermentation, so basically we will produce the specific and functional high purity molecules with the help of these three pillars fermentation technology. Now, I'm going to discuss about how precision fermentation work on these fermentation technology in this new generation fermentation technology. So basically, the process of precision fermentation can be broken down in four distinct, highly controlled stages, which help to transform simple input into the high volume purified ingredients. And these four distinct parts are: first is designing and programming, second is the cultivation through the fermentation process, third is the production, and fourth is the purification. And these all four methods used in on the industrial level to produce certain enzymes, proteins, and molecules. So basically, in design and programming, the process begins in the lab where scientists select a target molecule such as example whey protein, beta lactoglobulin. They then provide a host microorganism, typically a well understood and safe strain of yeast or fungi, and with the specific genetic blueprint here or instructions. So here I'm taking the words genetic blueprint and genetic instruction, where we involve the microorganism with the food technology method, where we going to express some genes. We are going to introduce some gene DNA replication process in this technology, where gene get expressed and produce that required compound. So basically, in design and programming process, we select our target molecule, and we select our microorganism, and choose our specific target which we need to produce on the high level. So in second process, that is the cultivation. In this process, the programmed microorganism are transferred into the bioreactor and the fermenters inside the sterile conditions, controlled environment conditions, and they provide with a nutrient rich liquid media, which include the simpler feedstocks like sugar, corn, sugar canes, along with essential vitamins, minerals to support their growth and productivity. Okay. So, in the third step of the production, in this process, within the bioreactors, the microbes consume the food stocks as an energy source. Okay, and following their new genetic instructions, they begin to produce the target ingredients and secrete it into a surrounding fermentation broth. And this phase is meticulously monitored to ensure optimal condition for temperature, pH, and oxygen level, which maximizes the yield of the desired molecule. So this is the very important step of the industrial level production. In the fourth step, harvest and purification, once the fermentation cycle is completed, the content of the bioreactor as are processed. The target ingredient is separated from the microbial biomass through the filtration or centrifugation process. Okay, the resulting liquid rich in the desired molecule then undergoes further purification steps. to yield a final product of exceptionally high purity. The final ingredient is molecularly identical to its animal driven counterpart, but it completely free of the production microorganism as well as any lactose, cholesterol, or hormones associated with the animal agriculture. So these are the four processes which includes the precision fermentation, how precision fermentation works. So this in our next slide, here I'm going to discuss why it is game changer. Why this next gen fermentation is a game changer in the fermentation technology. So we will discuss about this because this fermentation technology actually works on different levels. If we will discuss about this sustainability, so the environment benefits are profound in the for the help of this next gen fermentation. Multiple studies and life cycles analysis suggest that the producing proteins via fermentation can reduce greenhouse gas emission by 70 to 90%, and land uses by over 95%, and water consumption by 80 to 90% when compared to traditional agriculture animal processes. Okay, so this represent a paradigm shift into the resources intensity of protein production. So this technology very fruitfully work on the sustainability. If we will talk about the efficiency and speed, so production occurs within the bioreactors, which are highly space efficient and can be located anywhere in the world, decoupling food production from specific geographical locations, climate, and weather patterns to ensuring a more reliable and resilient supply chain. So we will work also on the efficient and speed level in on the next gen fermentation technology. When we will discuss about the purity and customization, so this technology allow for the creation of highly pure specific molecule, and the final ingredients are free from the undesired components often found pathogens like salmonella, E. coli, and this level of precision also enables customization capability is particularly important for the plant based food sectors. So, where precision fermentation ingredients can be used to overcome common consumer hurdles related to taste, texture, such as adding meaty flavor and cheese like flavors. So, we can easily purify and customize our product using the next gen fermentation technology. If we will talk about the circular economy potential, we can use low cost waste streams like molasses, sunflower cakes as a feedstock for this technology and promote upcycling, reducing wastage, and lowering production cost as well in this technology. And if we will talk about the ecosystem enables in this technology, basically not just a plant based alternative we can use, enhances the plant based products as well as by supplying critical sensory molecules like hemp, whey, and support a symbiotic model plant based for the bulk and fiber fermentation flavors and functions. And we will also work here for the favor as B2B ingredient supplier strategy, marketing fermentation companies like key players, and alternate protein improvements. So these are the basic requirements we will fulfill with the help of this next gen fermentation technology. Now, in our next slide, here I'm going to discuss about the innovations which are at the present time or very main focus on the concept of the fermentation. What are the fruitful technologies we are using? So, innovation in functional foods and nutraceutical, basically, there are the four main areas where we will focus. First are the we will discuss about the functional food for the nutraceuticals for the market growth and opportunities. So if we will here we will discuss about the driving forces behind the trend. So increased health awareness. So at present there are so many health awareness in everyone's where we being healthy and rising healthcare cost and aging global populations better understanding of the diet diseases. Basically, functional foods are defined as the food products that offer health benefits beyond basic nutrition, having been enriched with specific health promoting ingredients. These can include basically vitamins, minerals, proteins, omega 3 fatty acids, prebiotics, probiotics, and they all are provide the health benefits. Though they are also included in this technology. Now, third one, when we will discuss about the nutraceuticals. So, nutraceutical, term derived from the nutrition and pharmaceuticals. So, refer the substances derived from the food sources that provide extra health benefit, often sold medicinal forms like capsules or powder, and they are typically used to support overall wellness and target specific health concerns such as digestive health, weight management, and immune support. So nutraceutical streamlines is also worked on a vast level of food fermentation technology. And if we will discuss about the market growth and opportunity, the market of these products is substantial and expanding rapidly, while specific valuations vary depending on the scope of the analysis. And consensus reports places the market value of the hundreds of billions of dollars with a strong projected compounds annual growth rate over the next decade. So the powerful market demand create a fertile ground for technology that can produce functional ingredients in a more effective, sustainable, and scalable way. So these are the functional food and nutraceutical point of view. If we will discuss the fermentation superpower for the nutritional point of view. So there are some points like nutrient accessibility, breakdown of anti-nutrients, results, and improved digestibility. So here I'm going to discuss one by one. Like if we will discuss about the this technology, so during fermentation microorganism produces enzymes, most notably like the phytase, which effectively degrade these anti-nutrients, and the result are striking. Scientific studies have demonstrated that fermentation can dramatically increase the bioavailability of these minerals. So one human study found that the fractional absorption of iron from lactic acid fermented vegetables have approximately 100% higher than their fresh compounds. So another study rate showed that 240% increase in zinc absorption from the diet of fermented cassava flavor compared to unfermented flour. So if we are using the fermented food, we are analyzed that the our body are enabled to absorb more nutrient with the help of the fermented food. So beyond mineral availability, fermentation also improves the digestibility of complex proteins and carbohydrates by breaking down into the simpler, more easier and absorbable forms. So, furthermore, consuming the fermented food has been shown to have a direct and positive impact on your gut health. So, this is the main benefit of the fermented food, and everyone, I think, in this era likes to consume the fermented food because of their health. Everyone concerned about their health. So, our in our next slide, basically, our concept of the fermentation involved the animal-free revolution. This is the main motive of the fermentation in this new era, in this modern fermentation technology, because there are so many peoples are there which have going to change in the vegan form, and they are not like to consume the non-vegetarian foods. They wants to consume animal free food. So precision fermentation technology also works there. Here we can get all the benefits from the food which we are getting from the non-vegetarian foods. We can get these all the macro and macronutrients from these animal free foods. So precision fermentation technology role to create a animal identical proteins without using animals and meet consumers demand for ethical, sustainable and high performing food products. So first we come on the here I'm going to discuss about the dairy proteins. Several innovative companies are now producing bio-identical whey and casein protein. These proteins are the key to the unique functional properties of dairy products. The creaminess of ice cream and the stretch of the mozzarella cheese and the smooth texture of the yogurt. By producing these proteins through the fermentation, company can create dairy products that are molecularly identical to the original but are naturally free from the lactose, cholesterol, hormones, and antibiotics, and all while having a significantly smaller environmental footprints. So, this technology also work on the dairy concepts. And when we talk about the egg protein, so the technology is also being applied to produce the animal free egg white protein like albumin, which are crucial for baking, providing a structure, aeration, and binding properties in a vast range of food products. So, we can also produce these egg proteins with the help of this precision fermentation technology. If we will talk about the hemp protein, this is perhaps the most famous example is the use of soy proteins, or we call as hemp, by impossible foods because they are produced via the fermentation using a genetically engineered yeast, and this molecule is the key ingredient that give the impossible burger its characteristic savory meaty flavor and its ability to appear to bleed when cooked. So you can also enjoy that meaty flavor, that texture in the vegetable soy sandwich. Okay, so there are so many vast use of this precision fermentation technology. You can produce any protein, any enzyme of your required product. if we will talk about the collagen and gelatin, so animal free version of collagen and gelatin are being developed for the application across the food, beauty products and nutraceutical industries, demonstrating the incredible versatility of the platform. The company Gelator has even produced gummy snacks using collagen protein derived from the DNA of your extinct mastodon. So basically, there are so many products also available in the nutraceutical industries. They are directly giving you the benefits which you are found from the animal products. Okay, so this technology also very helpful for the industry level. So numerous pioneering companies are emerging and focused on high value ingredient across multiple sectors. They all are using the this technology. Basically, USA are majorly involved in this technology, and USA, Israel, Germany, Singapore, these are the major countries which are directly involved in this production. USA also producing egg white proteins on the large level. USA also producing the hemp on the large level. Collagen and gelatin capsules also producing on the higher level, which are animal free. So this is the benefit of this technology. So if we will discuss on the fermentation as a microbial pharmacy, basically here we are discussing about the sustainable biofactories and vitamin productions. So if we will discuss about the fermentation produces the high value nutraceutical compounds more efficiently and sustainability, we are also able to produce the vitamins as well. The commercial production of several essential vitamins, including vitamin B12, vitamin C, vitamin B2, and already released heavily on the microbial fermentation process. And this biological approach is a green, low cost and high purity alternative to a complex chemical synthesis pathway. Normally these vitamins get produced from the different chemical processes. Now this technology is here. You can produce on the industrial level these vitamins with the help of the fermentation technology. Now if we will discuss about the antioxidant and bioactive compounds, the fermentation can be used to significantly increases the concentration of beneficial bioactive compounds in the food industries. These included the powerful antioxidants like polyphenols, like flavonoids, and which are released from the plant cell walls by the microbial enzymes during the fermentation process. This is a very easy and suitable method to make these antioxidants naturally with the help of the fermentation technology. And if we will discuss about the antioxidant, here are the concept of GABA. Why aminobutyric acids? A non-protein amino acids that function as a major inhibitory neurotransmitter in the brain. This is a major product which are also using by the chemical industries. So fermented food enriched with GABA are being explored for their potential to reduce stress and anxiety. So this is also a one product producing by this precision fermentation technology or different pillar. So third one is the bioactive peptides. This is also a very useful concept for the nutraceutical industries. There these are the actually short chain of amino acids Okay, and these are liberated from the larger proteins during the process of the fermentation, and they have been shown to process a range of health benefits including antioxidants, anti-hypertensive, anti-inflammatory, and antimicrobial properties. So these compounds are also very essential for our health, and these compounds are now being making for the help of these fermentation technology. So in this fermentation presentation, now you can see that there are so many beneficial compounds, and there are so many beneficial products you can make from this fermentation technology. Now if we will discuss about the only the gut health, so there are one more concept also used in the fermentation technology, that is the probiotics and postbiotics. The scientific breakthrough, the fermentation is the central to nutritional science due to its role in enhancing gut micro flora in your health. So basically, the growing scientific understanding of the gut microbiome role is overall health. Are placed fermentation at the center of the nutritional science. So basically, this had led to innovation in two key areas actually. First is the key generation probiotics, and postbiotics, sorry, and the what are the target health benefits includes. So if we will discuss about the next generation probiotics, for years the probiotic market have been dominated by strains from lactobacillus and bifidobacterium genera, so typically isolated from the traditional fermentation foods. Basically, the next generation of the probiotics, however, involves the novel strains sourced directly from the healthy human gut microbiome, and these organisms such as one example is the Faecalibacterium, and second one is the Akkermansia are being intensively researched for their targeted health uh, benefits, including improving the metabolic health, and strengthening the gut barriers and modulating the immune system. So basically, this concept of probiotics basically comes from the fermentation technology, and these are the microorganisms help your gut directly from the concept of this probiotic fermentation technology. And if we will talk about the postbiotics, basically the emerging category represent a significant paradigm shift. The international ISAPP, that is International Scientific Association of Probiotic and Prebiotic, defined as postbiotic as a preparation of inanimate microorganism and their components that confers a health benefit on the host. In simple terms, basically, postbiotics are the beneficial compounds that microorganism produce during the fermentation, such as short chain fatty acids, enzymes and peptides, and cell wall fragments. The key advantage of postbiotic is that they are not live organisms. This makes them inherently more stable, give them a longer shelf life, and allow them to be incorporated into the much wider variety of food products that undergo process like baking and pasteurization process, where live probiotics would not survive. And this innovation effectively decouples the health benefit of fermentation from the need for live cultures, massively expanding the potential for creating new functional foods and making these benefits more widely accessible. So basically, the concept of probiotic and prebiotic, this is a powerful synergy, is a immense potential for rapid market adoption and disruption. So this is also a one concept. If we will talk about the gut health. So the advantage of gut health, probiotics and postbiotics, is they are using the not living organisms, more stable, longer shelf life, and can be used in heat processed food like baked goods, pasteurized drinks, and expand access to fermentation's health benefits without needing live cultures. So these are the benefits. If we will discuss about the market strategy and adaptation, so there are driven by the convergence of three mega trends here, initially discussed before: traditional biomass and precision. So, demand for the sustainable and ethical food alternatives, we will also use that, and interest in functional food and personalized nutrition. You can get that benefit also, and you can explore more research on the gut microbiota with the help of this technology. And fermentation enables health promoting ingredients that align with all three trends. So basically, position for the rapid market growth and disruptions, you can adapt this technology. So, if we will talk about the fermentation in agriculture, you can use the sustainable farming models. You can use the feeding materials for the microbial biofertilization process, and there are so many benefits. So, with the help of this fermentation technology, you can also improve your agriculture as well. So, if we will talk about the agriculture, you can basically fermentation circulate efficient and eco-friendly level of agriculture system reduces basically a synthetic fossil fuel based inputs. So you can use these fermentation products for your agriculture production. So basically, if we talk about the microbial biofertilization process, basically biofertilizers contain live microbes that enhances soil fertility and plant growth, and produce via a large scale fermentation of beneficial bacteria and fungi. So basically, like nitrogen fixing bacteria, phosphate solubilizing bacteria, you can also use these. Both the bacterias are in the fermentation technology, and there are so many health benefits like improve soil structure and nutrient cycling, support regenerative agricultures, and reduces chemicals runoff and environmental degradation. So you can also use these technology in the field of agriculture. And here we are also producing some biopesticides also here with the help of the fermentation technology, because fermentation produces biopesticides like microbial agents that target that pest naturally, and production via the solid state and the submerged fermentation process. The most common example is the bt, bacillus thuringiensis, produces protein toxic to insect pest and safe for other organisms. So advantage of this technology is target is specific, biodegradable, and resistance, and ideal for the integrated pest management strategy. And there are so many benefits of this technology because they are improved your crop quality, and they are providing nutrients to your crop and enhance gut health via lower the pH and beneficial microorganisms, and better growth and immune system, and reduced antibiotic uses, and cost effective by utilizing the local and low cost feedstocks. So this is also helpful. So, if we will talk about the bioeconomy, fermentation transform the agriculture waste into the high value inputs, and enables a shelf sustainable sustaining cycles, minimizing the waste, maximizing the resources efficiency, and reduces dependence on synthetic inputs and support a regenerative food system. So basically, these are the parameters which help in the agriculture concept. So overall, the workshop strategy is the fermentation enables sustainable, resilient food system. Nations will support ecosystem, will lead the bioeconomy revolution with the help of this technology. And the conclusion of this concept is next gen fermentation is reshaping food, health, sustainability, and collaboration across science and policy and public engagement is vital to unlock its full potential. So next gen fermentation represent more than just a novel method for producing food. It signifies a fundamental paradigm shift in our relationship with nature and technology. So I think this workshop would be helpful for you all. Now we will taking some questions. Uh, अगर आप लोगों के कोई भी क्वेश्चंस हैं आप कमेंट बॉक्स में सेंड कर दीजिए तो वी विल टेक द क्वेश्चंस. एनी क्वेरी अगर है फ्लेविन लैब्स के रेफरेंस में कोई क्वेरी हो या फिर आज की वर्कशॉप से रिलेटेड कोई भी क्वेरी हो तो यू कैन गिव इट टू द मेल बॉक्स.
Hello everyone. We'll take a short break of 2 minutes, and in that, please be with us. Please keep posting your questions so that we can take more and more questions. So we are waiting for the questions so that we can prepare the list and start answering your questions. Thank you.
Yeah, we are here. Now we are taking the questions.
So the first question is there any disadvantage in this fermentation?
Yeah, if is there is advantage, disadvantage is also available here, because if you are not using certain temperatures, certain growing conditions, and certain nutrients, then this fermentation have also so many disadvantage for your technology.
The next question is from Anu Yadav. Which type of sugar is best for fermentation and why?
Which type of sugar? Okay, so basically, more sugar like monosaccharides are also very useful for the fermentation technology. Like, जैसे मैंने one of the example is sugarcane. Sugarcane is best example for the fermentation process. So because microbes initial food is starch or a sugar, so here we are using the sugar material for starting the fermentation process, because microbial metabolism depends on the sugar availability in the food products.
Next question is can fermentation produce protein and will pressure stop fermentation?
Yeah, definitely. Now, I'm today I'm discussing also for the biomass production, the single cell protein. This is also a part of the protein production, and here microorganism itself are the proteins, and definitely the sorry, what the next?
And will pressure stop fermentation?
Yes, yes. Uh, I'm not saying कि it's stop the fermentation, but definitely if pressure is created, it affects the technology on the certain levels.
Can you please explain postbiotics in detail and how they are different from prebiotics and probiotics?
Okay, basically the probiotics yeah, concept basically on the beneficial microbes which naturally present on our gut flora. So probiotic concept are there when we are one of the example is if we have fever and we are taking antibiotics, so much antibiotics, so these antibiotics directly harm our gut flora. So here we need to increase our gut flora, so we are taking some probiotic drinks like lactobacillus, which are the natural microflora. And if we talking about the fruit as a natural probiotic, that is the curd and yogurt, which we are consuming every day, daily need foods. So these are the probiotics. And if we will talk about the prebiotic are the food where my beneficial microflora feed on that products, that is the prebiotic. So if gut flora are present our intestine, तो intestine का जो outer surface is the prebiotic. Actually जो surface है, the surface is prebiotic where microorganism feed on that surface, that is prebiotic.
Can you explain postbiotics in detail?
Postbiotic actually in the today's workshop we will also discuss the concept on the prebiotic and postbiotic basically emerging category. Basically it represent a significant paradigm shift. Actually they work on some concept, basically international scientific um, um, International Scientific Association for Probiotic and Prebiotic defines a postbiotic as a preparation of inanimate microorganism and their components that confer a health benefit on the host, that are the postbiotics.
Okay. The next question is what is the mechanism of action of probiotics in maintaining gut health?
Uh, the same answer is because the probiotic, no?
Yeah, probiotic.
Probiotic actually are beneficial microorganisms which are naturally present in our gut flora. So the main function of these microflora to digest our food and maintain the pH and acidic environment of our gut flora. So these are the benefits. So this probiotic concept comes when the we when we will discuss about the health of our gut flora. So we will take these natural microbioorganisms with the help of the probiotic drinks and probiotic food to increase their numbers. That is the probiotics.
Can we use AI in this technology?
Definitely, AI is at present, AI is everywhere. So these AI technology also work on the fermentation technology, and definitely it works on the fermenters and bioreactors, and give the instructions to the fermenters. Like, if we will involve the genetic engineering process, so AI definitely work on that.
Next question is, can you please tell me that how this precision fermentation is different from batch, feed batch, and continuous main aim of precision fermentation, where it's used in this industry? Basically, how precision fermentation is different from feed batch and continuous main aim of precision
The
fermentation.
precision fermentation technology actually based on the specific compound. If we need to produce some specific compounds, then we will go for the precision fermentation technology. Like, if certain vaccines are developed in the industrial level, so these certain vaccines also worked on some certain diseases. So these precision technology actually meant for the producing of certain molecules which work on certain diseases, certain compounds which are helpful for our health.
There is one more question. What are the different modes of fermentation?
Yeah, definitely. There are certain different modes of the fermentations. Like, if we will discuss about the metabolic capability of the microorganism, then that is the lactic acid fermentation, that is the alcoholic fermentation, that is the acetic acid fermentation. And we will talk about the operation modes, like open system, closed system. And if we will talk about the supplement system, then we will definitely a fed batch fermentation also available. So we will differentiate the fermentation methods on the basis of these different points.
वीडियो म्यूट कर दीजिए शिवानी बैठ के
So, everyone, I hope this session was helpful for all of you. This is the end of the session. If there is any more questions left, so we'll post the answers in the community, or you can ask the questions in the community as well. We'll share the feedback form in the community, so please fill the feedback form so that we could understand that what we can improve in the next workshop, and what are the topics that you would like to know more about. And all those students who think that this workshop was helpful for them and they want to take the certification to enhance their CV, or to present somewhere that they know about fermentation, you can yet apply for the certification. So I hope you have learned, and we are really thankful to ma'am, Dr. Shruvi Srivastava, for taking this session. Now, this is the closing time. So, thanks a lot for joining. Be with us for the next time. Thank you so much, and please fill the feedback form. Thank you.